computer. All right. So share screen, I can do that too. Okay. So we will go ahead and just get started with problem number one, I guess. The first stuff is just is figuring out how to compute the mean. There's quite a bit of problems on the standard deviation versus the variance. And then there's different versions of standard deviation and variance as well. Okay, so that's what these first set of problems is about. They give us a series of measurements here, and they want us to, they tell us that the mean is 12, and they want us to compute the population standard deviation here, okay? So that word, maybe not all of it, the population here, you're gonna have to pay attention to that because there's a difference in how the standard deviation is computed depending on if it's the population or the sample, okay? And it has to do with some stat theory that we're not gonna get into today, but the denominator, whenever we have the population there, the denominator is just divided by n for population, and then we use n minus 1 in the denominator if I have sample, right? How we're going to attack it is not doing all of this by hand, certainly, but just using our calculator. So let's drop into the TI calculator. I'm got a 84 emulator here, so if, again, it should be real similar just from the quick glance that I looked at on 86 or 36 or whatever is the number that you guys have to use. It's going to look similar. I need to go under the stat button there. That's where we're going to spend most of tonight. Okay. And I create lists in the TI operating system. That's how things get done. So if I just say enter, I can get my available lists that I can type data into. So let's go ahead and do this for this first example. The data for the first example there are just 11. So it should be the same on your 36. Is that true? Looks the same. Is there only one of you that has the 36? Everybody else? Okay. So just get that data entered, which on your exam is going to be a short collection of numbers here. And from what I understand, you guys get to use that calculator on the whole exam, right? They don't have like do these problems without a calculator and then do, okay, that's good. So 11. I'm going to go ahead and because the next problem has a different set of numbers, so I'm going to go ahead and enter in a second list right away. Okay, so the next problem, they only use that L1 list. We're only going to use that L1 list once here. So the second problem has the numbers 5, 2, 6, 3. It looks like. Okay. So once we get that data in, I'm going to show you how to get use obviously the calculator part, the single variable calculator, and then we'll identify the different parts in there. So once the data's in, that's good. I'm doing again a couple of lists here. I'm going to hit enter here. No. I need to get back. Just a second. Should get me back to, or just click on stat. That'll get me out of that editor mode. And now I'm going to, now that I have the data entered, I'm going to ask it to do some calculations. So again, I'm on stat here. Move it over to calc. And it'll ask you, what list do you want me to calculate? your summary statistics on. That's going to be the L1 list, obviously, for problem number 1. Okay. So I'll go back there and do that one more time for you. Yeah, 1 var second. Is it slightly different on the 36? What do you got, just so I can get it on the recording? Yep, so you're looking for one variable. We're gonna have to be, you guys are gonna have to help me, because with the recording, I want to get it on the recording of what it, that, on that calculator. So it's second stat and then 1 var, which is going to look the same as this here. I don't know. Okay, second data and then 1 var. So you're looking for the single variable stat is what we're looking for in your menu. Okay, once we get that activated or whatever, it's going to ask you what list do you want to calculate your summary statistics on. We put that, for the first problem, we put that in L1. So all I need to do is just enter here, or calculate there, and then that'll calculate those summary statistics for me. Okay. The mean, okay, is 12 for this data, I guess. They tell us that in the problem, so we don't have to worry about that. The mean, the population mean is divide by n. The sample mean is divide by n. So when we're talking about means, doesn't matter if you're talking about population or sample, they're both divided by n. Now, when I do variances or standard deviations, population is divided by n, sample is divided by n minus 1. We got a little variation there for standard deviations. All right. So they only give me one mean because the formula is the same whether I'm talking population or sample. The mean is 12. When I get down here, S of x, okay, S of x here is the sample standard deviation, right? Sample standard deviation. Now, if you go to the solutions for your problem set, I showed you all of the formulas all written out. Maybe I'll go show you that just quickly here. I'm not going to spend a lot of time with the solutions, but they're there for you guys. So here's the solution sheet. The calculations for the standard deviation are somewhat involved. Okay, and it is asking for the population standard deviation for this first problem. So there's my divide by n in that equation. What we're doing with the standard deviation is looking at the formula here, xi is just the different data values. So, and mu is the mean. So the essence of the standard deviation is how consistent are my observations against the mean. Okay, if all of the data was 11, 11, 11, 11, 11, 11, 11, 11, my mean would obviously be 11. My distance away from the mean would all be 0 if they're all the same value. So if I had data 11, 11, 11, 11, 11, there's no variation in that data, and my sample standard deviation and my population standard deviation would be 0 in that case. There's no variation. So what is the standard deviation doing? It's just looking at the compactness of your data. How concise is your data? How close together is your data? Okay. If you got a lot of variation, then I'm going to end up getting a big difference between my data value and the mean. And then on top of that, I square it. So that's even blowing the numbers up even more. Okay. So you end up, again, the idea of a standard deviation is just measuring the compactness against the mean. All right. This is the population version. I knew that, or I know that because it has n written on it. I think the next problem down asks us to do the sample standard deviation. It's the same stuff. It's just that I got that n minus 1 in the denominator now instead. If on the exam they're asking you for the sample standard deviation, you're going to want to use SX. It's easy to remember. S sample. Sample starts with S. Okay, that's standard notation. SX is the sample standard deviation. The sigma X, the one below it there, obviously, 1.118, okay, is going to be our population standard deviation. So this problem, I don't even know what we're doing here. The first problem asked for the population standard deviation. Is that what the first one was? On L1, right? So I'm doing my summaries on L1, 1.18. Oh, excuse me, 1.118 or 1.12. So first problem, good job. We got the first one done. Let's get, be annoying with that zoom bar there the whole time. It's all right. First one, 1.12. D, I guess, is the answer to it. Okay, let's go try that one more time with our second list. L2 now is where I put the second set of data there. So let's go over to the emulator there. I want to do second data for you guys. Okay, second data for you guys. You're going to do the single var again, single variable. Now I want to use the L2 list, which I can just specify that L2 list. Assume that that's something similar on the TI-36. Somehow you need to get the L2 there. We're not going to touch the freak list on this at all. We'll get to that one. Enter, and you'll get these summaries there for the. On problem 2, I believe here they're looking for the sample standard deviation. So we want to be grabbing 1.825 for that one. Now, they're not dumb. The people that make the exam, they're going to give you both SX and sigma X on the exam, right? Because those are the two that are on your screen, on your calculator. You gotta just whatever, memorize it if nothing else. The S of X is for the sample. And that's standard notation, no matter what. Okay. S of X is always the sample. The sigma is and these are all standard deviations. We'll talk about the variance here in a minute, or maybe that's the next one. Yeah. Problem 3, actually. Okay. So that one was, what was it? 1.5 or no, 1.83. Again, make sure you're grabbing the S of X there. Oops. Control B. Well, I don't know if you want to take notes here or not, but this is the X version on calculator. The variance now is going to simply be the standard deviation squared. Okay. The variance is the standard deviation squared. If the the solution sheet, the variance is just the inside part of this formula here. Obviously, that would be the sample variance. All right, because I have the n-1 on the denominator there. If I wanted, they're asking for the population variance, I think, in problem 3. So I want to use the n version of this. Okay, I want to use the n version of that, which is this one up here. So this here would be the population variance, the inside of that. The problem with the population variance, why we don't use the population variance, is it's on the wrong scale. Okay, everything gets squared, right? So in this formula, you got the data value minus the mean. So if we're talking millimeters or something, if I subtract two numbers that are in millimeters, I still get millimeters. But as soon as I square them, now I got a jacked up. I'm on a millimeter squared scale. So the population, the variance, excuse me, the variance is used, but just to get to the standard deviation. I don't know why they're asking you to compute the variance, because we don't ever use the variance. Well, I shouldn't say never, but we want the mean and we want the standard deviation, because those are on the same units as the data that we are working. That's why it's square rooted, because the units are all squared. The units are squared. Well, how do you take care of that? Take the square root of it after you messed it up. So that puts it back on the original scale. So can I do that on a calculator? My calculator. I could not find the under one var the variance value. But if they want population variance, all I got to do is take 1.58 and square it. Right? I mean, if we know what that simple formula, that this variance is just the square of the standard deviation, just take 1.58 squared, whatever that is, 1.58 squared, boom, boom, 2.5, 2.49, whatever we're there, 2.50, yep. Back over here, 2.50 would be the population variance. Okay, we okay with the differences between those two? Sample versus variance. Okay. We're not going to, even though the solutions have all of this stuff written out in detail. You don't do this, just use a calculator. I mean, my goodness, just use a calculator. Just get used to get comfortable with using the calculator is what I'm going to certainly advocate. Okay, let's talk about grouped data a little bit. Not real common. I don't want to quite say you probably won't see this, because then as soon as I say that, they'll throw a stupid grouped one on the exam. But we don't deal with this very often. What the grouped data means is that you have many, so the value here is 0.5. And I actually got 5 of them in my data set. So that's what we mean by grouped. These are the values, and then these are what we call the frequencies. Okay. The bigger name for that is grouped data. So if I had to write out my data here, if I had to write out my data for this data set, or if this data was in an Excel sheet or something like that, it would have 0.5, and there would be how many of those? 5 of them, is that what I had? Okay, and then I would have how many 0.2s? 10 of those, blah, 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 all the way down the line. You're gonna have a whole crap load of ones at the end, 45 of those ones at the end. Okay, so there's a whole bunch of them. So that's, instead of, I mean, in the olden days, I guess, or back when I was young, doing calculations were more of a pain in the butt. So if we could group the data up first, that's what we did. In 2023, I don't know if we really need to worry about doing all of this by hand. Okay. The calculator allows you to work with grouped data. So let's show you how to do that. So you're not typing in a list of whatever do I ever have, 45 and 20, 65, 75, 80 numbers. I mean, you could, if you wanted, type in a list with 80 numbers and you would get the same answers as you would with the group data formulas. Okay. So let's do a grouped data or a frequency list in the TI calculator. So let's go over here. I need to get back to my lists, which is the data, and then enter. I'm going to move over here into L3 and L4 is where I'm going to put my values here. So again, I'm just going to create the list of values, 0.5, 0.2, 0.8, and 1. So I only have in this data 4 different values, 0.5, 0.2, 0.8, and 1. And then I want to put the frequencies over here in L4. So just in another column, let's put the frequencies. So there's 5 of the 0.5s. There are 10 of the 0.2s, 20 of the 0.8s, and 45 of the 1s. So here I'm getting L3 and L4 here. One of them contains the values, the other is going to contain the frequencies. So now when I go under my one var, okay, we're going to go under my one variable summaries. It's going to allow me to identify L4 as a frequency column. L1, excuse me, L3 is going to be my data column, and L4 is going to be my frequency column. Okay, so let's go into our TI 36 or whatever, and you guys help me. Hopefully this is the same again on the TI 36. You're going to go second data. We want to do calc, one var again. My list is going to be L3 because that's where my data values were at. That looks similar to you guys. Do you have a freak list? Hopefully you have a freak list option as well. Okay, getting a head nod there. Thank you. So that's where my L4 is going to be because those were my frequencies. So here on the L4 is going to be my frequencies. Again, this would be equivalent to typing out 5.5s in a list, 10.2s in that same list, okay, all the way down all 80 of those values. Okay, I mean, we could do it that way as well. This is just, I guess, a shortcut instead of having to type all those data values in. Again, in practice, as a practicing statistician, I never do group summaries. I almost always have just the raw data. So once we get that, we calculate. Okay, very good. And what are they actually asking for? Well, problem 4 says, give me the mean. That's the top one. 0.818 there would be my mean. And then problem 5 is asking for the sample variance. So, right, sample S, SX, 0.27 is the one I want for that. Oh, my bad. Sample variance. I messed up, Malone. Slow down. S of X is the sample standard deviation, right? So my bad on that one. Looks like their options on that test question, they didn't give me 0.27 as one of the options. So that would have, that's nice of them. I just messed that up here when I was talking to you. So number 5 is a sample variance. So I got to take, what is it? 0.27 and square it, whatever 0.27 squared. That's 5. Number 6 is give me the sample standard deviation, right? 6 is sample standard deviation. So that's going to be the 0.27. Okay. That's group data. Again, the only difference there is when I'm doing my summaries, I'm going to take advantage of the freak list, which just stands for frequency. The freak is just give me the frequency. What column do you have your frequency? All right, now let's move on to problem 7. Okay. Problem 7 here is asking about a first probability calculation. Suppose a new value is sampled. What is the approximate probability that this value will be less than 0.9? Now, I didn't give you the entire stem of the problem for this, but they said up above, okay, that the data came from a normal distribution. All right, which I've never, well, whatever. They'll say whatever. That's fine. They say that the data comes from a normal distribution. The normal distribution is a continuous distribution. I've never seen 4 different values look like a bell curve, but whatever. That's what they're telling us. We're just going to calculate a probability based off of that. Okay. So what I need, so let's show you how to do this in a TI, because even on the TI 36, I'm pretty sure it's the same, at least a little bit that I looked at it before. You're looking for distribution. So DISTR, or which I think is still under second data for you guys. So you guys are going to go second data, and you're looking for distribution. I think it's off to the right there. You have calc, maybe test, and then DISTR. Okay. Now, we're going to work if they ask for a normal probability, okay, which is by far most common probabilities that we work with, it is the normal CDF. I wish normal CDF came before the normal PDF on this calculator, whatever app. CDF is what we want. Let me show you maybe the difference between a PDF and a CDF. All right. So what is the difference there? I need to go to the solutions here. Come on. I'm going to just grab this app here. What is the mean for our data? 0.82, yep. That's what we found in problem 4. Problem 6 is, what is the standard deviation? Standard deviation here is 0.27. Now I'm using an app here, but I'll show you how to do it in the TI here in a minute. So where did I get this app again? What are you doing here, Malone? If you, again, you don't have to, I'm going to show you how to do it in the calculator. I'm just trying to describe what we're going after here using the app. So that, again, the link for the app is in the solutions. In order to calculate a normal probability, I need to know 3 things. I need to know, what is your mean? Okay. What is your standard deviation? And then what endpoint or endpoints, could be 2, are you working with in computing this normal probability? Now they wanted to know, what was it? Less than 0.9 is what the question was. So my point of interest here is 0.9. And then they want less than. Okay. So the app gives me what that answer is, but unfortunately on the FE exam, you can't use the app. I wish you could, okay, but you can't. But what is happening when I put in the 0.82, the 0.27, and a value of 0.9? 0.82, the mean, is just telling me where that normal distribution is centered. So on the screen there, you can see that it's centered at 0.82. If I change that to 7, then the mean or the center of that distribution is going to be at 7. Okay. So the mean is just telling me, where is this normal distribution centered at? The standard deviation is telling me how skinny or squished. Okay. If it's really skinny, the bell curve is really skinny, that standard deviation is going to be small. If that bell curve is really fat, then that standard deviation number is going to be large. So if I were to change this to 5, watch the number line there. Watch the number line on the screen. If I were to change that to 5, it's going to blow that normal distribution way up. Okay. The data values here change drastically. But our standard deviation is pretty small at 0.27. So that's going to shrink that down quite a bit. Then the point of interest is 0.9 here. Now, when it computes, it said less than 0.9, right? Less than 0.9 is the probability they're interested in. You can see on the screen here that the normal distribution obviously is a bell-shaped curve. And when we say less than 0.9, we're going all the way down to the left. And in fact, it goes off to negative infinity. There's an asymptote here, it never actually touches the x-axis. All right, it goes all the way down to negative infinity. But this probability is a cumulative probability. It is adding up as we go across the number line. So on the TI calculator, I want CDF, because what do you think the C stands for? Cumulative. It's adding up as I go through that distribution. Don't use PDF, because the PDF is actually telling you how tall the bell curve is at each point. We never use it. I mean, we use it if we're plotting, but other than that, we never use it. If they are asking for a probability, okay, then we want to use the CDF all the time. We don't want the height of the bell curve. We want to know what this red area is, the cumulative probability. So let's go back over to our calculator, our TI here. And what were we doing? We were doing second data, and then I want to get into the distribution menu. I want the second one down, which is the CDF. Again, I don't know if you're going to remember, the C stands for cumulative, but that's what it is. It's a cumulative density function. Excuse me. CDF is a cumulative density function. And that's what we want if we're going to do any probability type calculation. All right, so say okay there. Now, sorry. Down, say enter there. Okay, I'm getting one var stats. I want to draw it. Why am I getting one var stats here? When you guys do that, what are you getting? Yeah. That's exactly what I should. Yeah, it should be the same, but that's that same menu. Yeah. Let me, and it was, I did this earlier tonight, this afternoon. Emulator. No. Oh, Fallout Boy, you want some music? TI 84, let's go, there it is. So on the, yeah. Try this one more time. Ridiculous. Okay. If I just go list, try it under the stat menu. No, I can't get to it there. Oh. Where's quit? Okay. Thank you for helping me. There it is. Go be. Learn something today. Let's go home. Learn something. Okay, so what I need here are, actually, I said 3 inputs. The app took 3 inputs that we were just looking at, but I do have to specify both the lower and upper endpoints of what I want to compute the probability over. So I want to compute the probability from negative infinity. Where is the app here? Go back here. Negative infinity. So I literally on the TI, I got to put in -1, okay, E99. It looks like on the emulator here, that's set in there by default. I don't know if it is for yours or not, but you do have to put that. If you're going, I think we got one coming up where we got to go off to positive infinity, then obviously we're putting 1 E99. All right, the other endpoint that I care about is the 0.9. I want my probability to stop at 0.9. I've been doing this for 30 years, probably longer than that now. Okay, if you go back to when I started learning stats, 1991 or whenever I got into school, long time ago, I still draw these pictures. These little bell curves help me understand what my left point is, what my high point is, if it's a between, whatever. I still draw these little pictures. Okay, I have no idea how many of these I've drawn in my life, but it's a lot. I guarantee you I'm not having one on my gravestone. Stick it, but whatever. Okay, so on here, when I'm doing this, I need -1, negative infinity, and then my, what, 0.9 was it? Was my upper side. My mean is 0.82, right? Boom, boom, boom. 0.82, and my standard deviation is 0.27. Now, a little bit of a hiccup here in the technicalities of things. We don't have to worry about too much, but as a statistician, a little hiccup here is they asked us to calculate the sample standard deviation. When we compute a normal probability, what we are actually using in there is sigma, which is the population standard deviation. All right, but I think the answer, that choice that we have here, is you don't have to go back and compute the population standard deviation. Okay, with well, how many data values did we have in this group date? 80, I think it was. So you're not going to get, well, one of them is divide by 80, and the other is whatever the numerator is divide by 79. You're not going to get much discrepancy between those two when you have a larger sample. So even if we were to go back and recalculate the the population standard deviation, technically that's what we're supposed to use there when we're computing that probability, probably going to get the same answer. I wouldn't think they would give you those two options as choices on the exam. So on those first couple problems, there was a difference between the sample standard deviation and the population standard deviation. I think one was like 1.58 and the other was like 1.11. That's because I only have 4 data values. So on one of them, you're divided by 4, the other one, you divide by 3. That's quite a difference when your denominator is so small like that, when your numbers are so small. But generally speaking, there's not much of a difference between the two. Okay, so again, what do I need? Lower end point, the cutoff, the mean, and the standard deviation, and then say compute. What that does is it actually translates it into just a command. Okay, so this is the command. You can go directly to this if you wanted. Again, it's the lower end point, the upper end point, the mean, and the standard deviation. It has to be in that order. 0.6164 is that computed probability. 0.6164 is that computed probability. So probably that one there, aside from just some little bit of rounding. The app, hopefully that gives me something similar. Let's go. 0.6165. Yep. But obviously you can't use the app. So, all right. Okay, drug you through quite a bit there. Let's do some more. Okay. So these are just pure normal probability questions. They're not making us go and compute the mean and standard deviations first. These are just pure normal probability questions. Thermometers are from a factory designed to register at 0 degrees Celsius, the freezing point of water. However, test shows that some of the thermometers are a little off, so we got some calibration issues here, basically. We do have a standard deviation, well, excuse me, we do have a mean. So what the important information that I need to pick out of here is the average is at 0, and a standard deviation is at 1. Okay. So my mu, that's mean. When I'm doing this on the calculator, my mean is going to be 0. My standard deviation is going to be 1. Okay. Let's go ahead and show you what this is going to look like on the app. 0 here, standard deviation 1. Centered at 0, standard deviation 1 here. And now they want us to do I think this one is a between. Okay, what is the probability that I select a thermometer that registers between -1 and 1. So this is on my calibration. If I'm trying to calibrate something, I'm off by a degree here. Okay. Which, depending on what you're trying to measure, a degree might be a lot. But under this scenario, what is the chance that I'm going to have these thermometers register within a degree? Under this model, it's a normal probability model. Okay, what is the probability that it's going to register within a degree of what the target is? Okay, so I need to go -1 to 1 on this one. All right, so on my app, okay, I'm going to need to go between, and it's going to be between -1 and 1. Now the app is set up a little bit different than the calc. Let's not even worry about the app anymore. You got to use the calculator on the FE exam. But what's my lower limit going to be on this? Yeah, -1. My upper limit's going to be 1, right? If you just sketch it out, I mean, this one's pretty easy. Understand what the negative limit is and what the lower limit and the upper limit is. But just a quick picture helps me understand where I'm going from and to. If we were having to use the normal probability tables, we would have to pay much closer attention to how we're setting up the lower endpoint and the upper endpoint. But if they're allowing you to use the TI-36, do not touch the normal probability tables. Do not touch any of the probability tables. Do not try to understand any of them. If they're giving you the calculator, just figure out how to get your stuff done in the calculator. It's way easier than trying to digest those several pages of probability tables. Now, when you look at the solutions, okay, I have those tables in there. But I'm just saying you can ignore that. That's why I went and saw Eric today, because I'm like, what is exactly the calculator that you're using? I went back to my office and I started searching quickly to make sure that this stuff could be done on calculators, on the calculator they're using for the exam, and it can be. So if you don't waste any time trying to figure out how to use the probability tables, whether it's binomial, normal, Poisson, t-distributions, chi-squares, the last time I looked, they give you them all. It's like 10, 12 pages of just, you don't need it. So let's figure out how to do it on the TI calculator. So again, we're going to go to second data, and you want that normal calculator again, CDF. Lower limit is what? -1. So clear. -1 is the lower limit. Upper limit is 1. Mu, which is going to be my mean, is 0 for this. And my standard deviation is going to be 1. All the way through here. And that normal probability is 0.6827. 6827. Okay, so whatever 6827 is D. Problem number 8, answer is D as in dog. Okay, let's do 9 quickly. Same setup, except register above 2. Above 2. Same setup. So 0, 1, my point of interest is 2, and they want probabilities on the right side. So what's my lower endpoint? 2. What's my upper endpoint? Positive infinity. Okay, so when I'm putting this in the in my calculator, again, I'm going second data. I need to get to the CDF calculator. But here I'm going, my lower endpoint is actually 2. My upper endpoint is infinity. So I can do that by putting in either some really, really large number or 1. I'm thinking of mine, it's second E here, and then 99. And then 0, 1, that's all the same. So make sure that's obviously +1, not -1, because that would be negative infinity. 0, 1, that's all the same. My answer should be 0.02 or something according to what I had just on the app. Yeah, sorry. One more time. 0.0227. Okay, number 10. Mean is 143. Standard deviation 29. They want to know the weight. What is the chance of a woman having a weight, I guess, between 140 and 211 pounds? So I think I can skip that one. We're going to use the CDF again, normal CDF. Mean 143, standard deviation 29. My lower limit's 140, my upper limit's 211. Solutions as whatever that answer is. Okay. Feel comfortable with normal CDF one? Playing around with that enough? All right, I'm going to hit pause here on my video.